All right, so now let's go ahead and look at some examples of simplifying cube root expressions. And really all the notes we had for simplifying square root expressions are going to apply here. We just have to tweak them a little bit. So we still have a product property for radicals and for cube roots. However, the cube root of a product x times y can be written as the cube root of x times the cube root of y, just switching those square roots over to cube roots. And because the way the cube root and cubic function operate and allows negatives to be involved, we don't have to have that condition where x and y have to both be positive. Also, to be simplified, a cube root expression should have all not perfect square factors factored out and reduced, but all perfect cube factors or perfect powers of 3 factored out and reduced. And there should still be no roots in the denominator, but this time no cube roots. So let's go ahead and look at some examples of simplifying some of these cube root expressions, starting with simplifying the cube root of 16. So very similar to our work with square root expressions, we start by using a product property for radicals to break this up as the product of 2 cube roots. In the first cube root, we want to find the largest perfect cube or perfect power of 3 that 16 is divisible by. And then in the second cube root, we'll just leave over the leftover factors or the non-reducible, non-perfect cube factors if we have any. So again, we might have to list out some of these perfect cubes, like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. But early on in that list, we stumble upon 2 cubed is equal to 8, and that's the key here, because 16 is divisible by 8. We can break apart 16 as 8 times 2, and that means we can break apart the cube root of 16 as the cube root of 8 times the cube root of 2. And we can start simplifying this because we now have a cube root of a perfect cube. What number do we have to raise to the power of 3 to get 8? Well, that number will be 2. So our factor of the cube root of 8 simplifies to this factor of 2, and our other factor of the cube root of 2 is irreducible, and so we just copy it back down, and this is our answer. We're done. This is as simplified as we can go. The cube root of 16 is equivalent and more simply written as 2 times the cube root of 2. All right, let's take a look at one more example of simplifying a cube root. This time we're simplifying the cube root of 108. And so in order to simplify the cube root of 108, we want to think about breaking this up as a perfect cube times a non-perfect cube. And so now we need to find that largest perfect cube or perfect power of 3 that 108 is divisible by. And as we kind of look through our list or table of perfect cubes, we should find that 108 is divisible by 27. So 27 is a perfect cube that 108 is divisible by, but then what goes in that second radical, that second cube root, is that missing factor we would have to multiply 27 by to get 108, and that should be a factor of 4. And so we'll now, to finish this off, we want to evaluate or reduce these perfect cubes that we're taking the cube root of, and that's just this cube root of 27. So to evaluate the cube root of 27, we have to think through and find the number that when raised to the power of 3 gives us 27, and that number will be 3 itself. So the first factor reduces down to just a factor of 3, and our second factor is irreducible. So we just have to copy it down and multiply it with that reduced factor. And our final answer is going to look like 3 times the cube root of 4.